In this video, I'm going to show you the float data type in Python. Floats are a type of data that represent real numbers. They are stored as 64-bit double precision floating point numbers, which means that the float data type can represent numbers of up to 17 significant digits. However, it is important to note that the actual number of decimal places displayed may be less than 17. This is because Python rounds the number to the nearest representable value when it is displayed. And like with integers, there are a couple of different ways to create floats. So as you can see here, I have my underscore float equals 1.0, and I have this decimal place here. And anytime you have a number with a decimal place in Python, it is a float. And if I output my float, it will simply output 1.0 here. And just like the integers have a int function, the float has a float function. So I could say my float equals float and then pass in an integer value such as 99 with no decimal or fractional parts. And when I output this now, you'll see that it outputs it as 99.0 and it has added the decimal place here. I can also pass in the string representation of a decimal, such as putting the value of 3.14 in quotes. And if I run this, I'll get the output 3.14 down here because it has converted this string to a float. Using certain mathematical operations also creates floats. So if I have the integer value 4 divided by the integer value 2, and run this, we'll see that it actually outputs 2.0, which is a float value. And this is because anytime you use regular division, it always returns a float value. And if I were to do something like 4 plus 2 and run this, we'll see that we get the integer value 6. But if I were to make this 4 a 4.0 and run this, now I get the output of 6.0. Because anytime that you use a float with arithmetics, if the type of arithmetic you're using doesn't explicitly return an integer value, it will always return a float value. So now I want to show you some of the limitations that floats in Python have. I'm going to replace this here with this number here, which is 0 with 18 digits after the decimal place. And as I mentioned earlier, the floating point precision in Python can display up to 17 significant digits, and this 0 to the left of the decimal is considered insignificant, so it is not factored into those 17 digits. Now, when I run this, where I try to output this number here, we'll see that it actually removes the 9 here from the end of the number, and it only goes up to 8. And Python does round the number up to the nearest representable value, so in this case, it did not have to actually change this number. But if I remove this decimal here and put it here after the 9, so I have 9 significant digits on the left side of the decimal and 9 significant digits on the right side of the decimal, totaling 18 significant digits. When I run this, I get the output where the 9 was removed and then the 8 was rounded up to 9. So I have 1, 2, 3, 4, 5, 6, 7, 9. And this was just an example of it rounding up to the nearest representable value. If you use a floating point number where there are more than 17 digits on the left side of the decimal, so if I add 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 here, it will essentially remove all of the decimal places and turn this number into a scientific notation version of it. So when I run this, I get this output here, which is the scientific notation version of this number here. And if we look at this, we can see that all of these numbers were removed and the 7 here was rounded up to 8. Now, if I try to convert my underscore float with this value here to an integer using the int function, so I'll do result equals, type in my int function and pass in the value of my underscore float and output this, we may not always get the result that we expect. So if I run this here, you'll see that we get this number here, which is not quite the same as the whole number that we had when we created my underscore float. You'll notice that the last 2 digits in this number are 6, 8, whereas the last 2 digits up here are 8, 9. And if I added just a single 0 to this and run it again, we'll see that now the last 3 digits are 1, 6, 8 instead of 8, 9, 0. So this doesn't always convert the number back into an integer the way that we would expect it to. So it's important to try to remember that if you are working with large float values and you are converting them to a different data type, you may not get the results that you expect. Due to how floating point numbers are represented in computers, performing calculations with floats can sometimes lead to unexpected results. So it's important to be aware of these floating point precision limitations and consider using the decimal module or other techniques for precise calculations involving decimal numbers. And one very simple example of that is if I have x equals 0.1 and y equals 0.2, and then I do z equals x plus y, and I try to output z, I'm not going to get the result as 0.3 like I would expect. I'm actually going to get 0.3 and then this whole bunch of zeros and this 4 here. And this is an example of how working with floats can sometimes generate imprecise values. And although this is an extremely small number, depending on what you are doing with this number, it could have a very big impact on the program. So just remember, when you are working with float values, there can be some imprecise results generated. So extra steps have to be taken to make sure that the program is doing what it is expected to be doing.